Welcome to my channel. Today we will be evaluating the integral of this function, this rational function. So we start off by using partial fraction to break this one down. So x squared plus 2x plus 5 divided by x plus 1 times x squared plus 4. This can be split into a over x plus 1 plus bx plus c divided by x squared plus 4. Here we can do cross multiplication. X squared plus 4 plus bx plus c times x plus 1, all divided by x squared plus 4. Can multiply the numerator out by distributing ax squared plus 4a plus distribute this one, bx squared plus bx plus cx plus c. All this one divided by x plus 1 times x squared plus 4. And this, we can group like terms, a plus b all to the x squared, because x squared, the coefficient of x squared has a and b, so we just group them together and factorize. The same for the coefficient of x, that is b and c plus b and c times x plus 4a plus c, which are the constant terms, all divided by x plus 1 and x squared plus 4. This is equal to x squared plus 2x plus 5, all divided by x plus 1 times x squared plus 4. The denominators are the same, so the numerators should also be the same. So we just do comparison. The coefficient of x squared on the left hand side is 1. The coefficient of x squared in the right hand side is a plus b. So by comparison, a plus b should be equal to 1. So we can call this equation 1. Next, the coefficient of x squared, the coefficient of x in the left hand side is 2. The coefficient of x in the right hand side is b plus c. So b plus c should be equal to 2. You can call this equation 2. And lastly, the constant terms. The constant term in the left hand side is 5. The constant term in the right hand side is 4a plus c. And that should be equal to 5. You can call this equation 3. When we solve these three equations simultaneously, which I'm not going to solve in this video to make the video long, so I will just give you the final answers to these values of a, b, and c when they are solved simultaneously. So solving these simultaneously, solving these equations simultaneously. The value of a is 4 over 5. That of b is 1 over 5, and c equal 9 over 5. That is the values of a, b, and c. So we can plug that back into our equation. So the equation we are required to integrate, which is x squared plus 2x plus 5, all divided by x plus 1 times x squared plus 4. This can be written as, let's scroll up, this can be written as a over x squared, a over x plus 1 plus bx plus c all over x squared plus 4. We know the value of a to be 4 over 5, the value of b to be 1 over 5, and the value of c to be 9 over 5. You can just plug that in. So that should be a, which is 4 over 5 over x plus 1, plus b, 1 over 5x, plus c, 9 over 5, all divided by x squared plus 4. So this becomes 4 over 5 times 1 over x plus 1 plus 1 over 5 times x plus 9 all over x squared plus 4. So our original function x squared plus 2x plus 5, which we are supposed to integrate, can be split into this function. So instead of integrating this function, we are now going to integrate this function. So we are now integrating 4 over 5 times 1 over x plus 1. This is plus 1 over 5 into x plus 9 all over x squared plus 4 dx. This can be split into 3 integrals. So the first one being integral of 4 over 5 times 1 over x plus 1 dx plus 1 over 5 integral of x over x squared plus 4 dx plus the integral of 1 over 5 times the integral of 9 over x squared plus 4 dx. This integral can be split into these 3 integrals. So you can call this one I1, call this one I2, and lastly call the last one I3. So when we are now going to integrate these integrals I1, I2, and I3 separately. So let's tackle the I1 first. So I1, you can do that in black pen. So I1 is equals to the integral of 4 over 5 times 1 over x plus 1 dx. So 4 over 5 is a constant, so it goes in front. Integral of 1 over x plus 1 dx. This we can use u-sub, but this straight away is just a natural logarithm of x plus 1. So you can use u-sub. We can let u to be equal to x plus 1. Then du dx should be equal to 1. So that implies du is equals to dx. So our integral now becomes 4 over 5 integral of 1 over u times du, because dx is du, and that is just equal to 4 over 5 times the natural logarithm of u. So you plug back u is x plus 1, so that becomes 4 over 5 times the natural logarithm of x plus 1. So that is the value of the first integral. The value of the second integral, I2, I'll do that in red pen. I2 can just call that one 1 over 5 integral of x over x squared plus 4 dx. The same u substitution, we can let u be equal to x squared plus 4. That implies du over dx equal to 2x. Meaning du is equal to 2x dx, and then dx equal to du over 2x. So it means wherever you see dx, we just put in du over 2x. And that we can take everything from the x world into the u world now. That is 1 over 5 integral of x over x squared plus 4. X squared plus 4 is u times dx. Dx is du over 2x. So this x and this x will cancel. This 1/2 is a constant, it comes in front, multiplies by 1 over 5, you get 1 over 10 times integral of 1 over u du. And that is just equal to 1 over 10 times the natural logarithm of u. But what is u? U is x squared plus 4. So we just plug that in here. So that should be equal to the natural logarithm of x squared plus 4. This is always a positive number, so there's no need putting it in absolute value terms. So that is the value of the second integral. Forgot to multiply by 1 over 10. Now the last integral is I3. So I can do that in green. That is the integral of 9 over x squared plus 4. So I3 should be equal to I'll call this 9 over 5 natural integral of x squared plus 4. X squared plus 4. So this, we can use the trig sub. So this is added trigonometric substitution. So we can let x be equal to 2 tan of theta. Can take the dx over the theta should be equal to 2 secant squared theta d theta. So what is the value of dx now? Dx should be equal to 2 secant squared theta d theta. So wherever we see dx, we can plug in this. So we can take everything from the x world into the theta world. So I3 should be equal to 9 over 5 integral of 1 over u. I'm sorry about that. This is integral of x squared. X is 2 tan theta squared plus 4 times dx. Dx is 2 secant squared theta d theta. So I3 is equals to 9 over 5. Integral of 1 over square of 2 is 4. Square of tan theta is tan squared theta plus 4 times 2 secant squared theta d theta. So that should be equal to 9 over 5. Integral of 2 over 4, that should be 1/2 times 1 over, that is the 4 was factorized out. Now you have tan squared theta plus 1 times secant squared theta d theta. So this is equals to 1/2 is a constant, comes in front. That should be 9 over 10. Integral of 1 over tan squared theta plus 1 times secant squared theta d theta. We know that secant squared theta is equals to 1 plus tan squared theta from the Pythagorean identities. So this can be further simplified into 9 over 10 integral of 1 over secant squared theta times secant squared theta d theta. This should be equal to 9 over 10 integral of 1 d theta, because the secant squared thetas will cancel out. So we are just integrating 1 in the theta world. So that should just be equal to 9 over 10 times theta. What is the value of theta in terms of x? X was equal to 2 tan theta. We know x is equal to 2 tan theta. So we have x over 2 should be equal to tan theta. We can isolate the theta. So theta should be equal to the arctan of x over 2. So the value of the third integral should be equal to 9 over 10 times the arctan of x over 2. So we have the value of the third integral in green, the value of the second integral in red, and the value of the first integral in black. So we can just put them all together, and that will be the value of our integral. So the integral of x squared plus 2x plus 5 all over x plus 1 times x squared plus 4 dx. Should do this in black pen since the original one is in black pen. Our original integral, which is integral of x squared plus 2x plus 5 all over x plus 1 times x squared plus 4 dx, should be equal to value of the first integral, which is 1 over 10 times the natural log of no, the first one is this one, 4 over 5 times the natural log of x plus 1. It's 4 over 5 times the natural logarithm of x plus 1 plus, that is the next integral. Next is I2. I2 is 1 over 10 times the natural log of x squared plus 4, which is 1 over 10 times the natural log of x squared plus 4, plus the value of the last integral. Last integral is 9 over 10 and the arctan of x over 2 plus the constant of integration. So this is the value of this rational function. So you can verify this by differentiating this. So if you want to verify your answer, you can differentiate this one, which is 4 over 5 natural log of x plus 1 plus 1 over 10 natural log of x squared plus 4 plus 9 over 10 arctan of x plus 2 plus c. When you do this, then you should be able to get our original function, that is x squared plus 4, x plus 1 times x squared plus 4. So this is the answer for this integral. If you find that helpful, like the video, subscribe to my channel, hit the notification bell for more content like this. Thank you very much for watching, and see you in the next video.